Welcome to the last part of the Resident Evil puzzle tutorial series. In this part, we're finally going to go over opening the door, and we're actually going to finish off our puzzle system. Although we had the rotating and all that working, we didn't have the tick functioning correctly, and we also didn't have anything for opening the door. First, we're going to get our last bit of C++ done, and then we will move to Unreal to do the last little bits. So this is going to be rather short. There isn't much to do in C++. I think most of the work is going to be in blueprints because we're going to need to make some materials and stuff like that for the painting and so on. We're going to need two things. First, we're going to need to get our interact so we can actually interact with this door. And we're not going to do it the player, but we're going to do it via the pedestal because the player can only interact via the overlap. So if we don't have an overlap, we can't interact. So hashtag include, then we'll say tutorial / re_interact interface .h, and that's our interface. And to add it to the actual class itself, we need to do comma public, and then we'll say ire, sorry, so ire_interact interface. And that's all we need. We're going to need a delegate. So we're going to say declare _dynamic _multicast and delegate. And a parentheses. And we're just going to call this fdoor event signature. Like this. Semicolon at the end of the line. And now all we have to do is one, make it so that we can call an event saying the door is open. So we're going to copy this, and in a protected section we're going to make here this, we're going to say on door opened with the event being the type. And we want to call this in blueprints. We'll say u property blueprint callable. Like this. And then one last thing we need is we need a blueprint implementable function called open door so that we can start opening door via C++ with our interact interface. But once it's done, we can let the system know from blueprints with our delegate here. U function blueprint implementable event, comma, meta is equal to parentheses display name equal to quote open door, and we'll call this void BIE _open door parentheses semicolon. Oh yeah, sorry, I forgot something. We still need our actual interact, so we're going to get that by going into our tutorial interface. So we can either control click here or we can search for it in here. I just like to control click, or apparently it doesn't exist. I think I mistyped it. Let's just go to our interact here and we'll copy this. That should be exactly how it is. So this is in the C++ file. Puzzle door, and let's paste. No, so that should be good. For some reason it's just not working and saying the file doesn't exist. So just go for it through here. And what we want to copy is our interact. So copy this, paste it in the puzzle door at the bottom here, and replace the curly brackets with override. And then we wait for this to load, and then we can create the definition like this. So we don't need to do anything with these three. So to be fair, we could delete them in our parent class. So we're going to do that, get rid of all these, and then we have to delete them in here as well. And all we're going to do is in here, we're going to start off by saying BIE _open door parentheses semicolon, which just lets the blueprints know that we are opening the door because the interaction just occurred. And we're just going to automatically assume if something interacts with the door, it's valid, it's succeeded. So we're just going to open the door. We're not going to do any other checks. Then we're going to say if ARE_pedestal pawn. Actually, we don't have a reference to this. So first we need to do hashtag include tutorial / re_pedestal pawn.h. And so now we'll recognize what this is. We'll turn this into a pointer. We'll say as pedestal pawn, is equal to cast, and we'll just copy this. Our interactor is the target, so like this. So if our interactor is a pedestal pawn, then we can use the rest of the system, which is going to be on door opened. We are going to add dynamic parentheses, and as pedestal pawn is the target this time instead of the usual this, because we want to bind it to the pedestal, not to this actor itself. And we're going to say and ARE underscore pedestal pawn, so that we can check in the pedestal pawn for the function that we need. And we're going to look for receive door opened, which we made last time. Then we're going to pass this as successful is true, and we'll then say return. Now, if for some reason the pedestal didn't, actually what we could do is we'll move this here. So at the very least, it only does something if it's the pedestal. And if it isn't, we will then say successful is equal to false. There we go. And that's all we have to do. Now we just have to compile it and go to our blueprints and get all the rest of the stuff done. So that's everything for C++. So Control F5, and I'll be back once it has loaded. Or if there's an issue, I will join you and fix that. So now that the project is loaded, we no longer need our IMC puzzle. We no longer need our fade to black. Pedestal we still need for a little bit because we're going to need to do this. And let's get into everything else we need. Let's start with our materials. So actually, before we do that, let's just go into our door here. So in our blueprints, make a new one, blueprint class, and we are looking for just door. And we should have RE puzzle door. A puzzle, we already made that, then why is it not? Where is it hidden? Why is it not? Oh, I just can't read apparently. Was it right there? It was right there. I'm blind. So open up puzzle door and let's set that up, and then we will be done essentially with all the blueprints, and then we can just work on the materials to finish things off. Okay, so this is going to be very simple. Barely going to do anything. We're going to add a static mesh here, and this is just going to be our door. It's going to be called SM underscore cube, and just the first one will do. The material, leave it as it is, and we're just going to say it to be 1 by 5 by 4, like this. Save it, and then we're just going to go into our event graph. We are going to remove all of this, we don't need it, and we're just going to get our override. We're going to get our open door here, click on it, then we're going to drag out and say timeline, add timeline, drag this into place start so that it always does it from the beginning. Rename this to, let's say, TL open. Double click to open it, set it to, let's say, 3 seconds, add a track, call it alpha. Shift click to add a point, set the first point to 0 time and 0 value. Shift click again for time 3 and value of 1. And we can close this. And from here, we are simply going to get our static mesh. We're going to set its relative rotation, split the new rotation, drag this into the update. And what we're going to do is from the alpha, we're going to say lerp. And it's going to connect to the A when we want it to connect to the alpha. So control drag. Then -90 on the B. And this is going to go into our yaw, like this. And to finish, once the door is completely open, we will call on door opened, like this. And now we'll go to our C++ through our interact and let the pedestal know that the door is open so you can release the player. So compile and save, and that will do it for our door. Now we just need to set it up visually, but first we need to do some last little bits. We're gonna need the pedestal for a bit, but first the material. Let's go and make it. Puzzle, right click, materials, and then we'll say right click, M underscore, let's just say painting, go, double click to open it. don't need to change any of the settings here. We're going to start with a texture, which we're going to turn into a parameter. So right click, convert to parameter, mask, texture. And we're just going to promote this to a named reroute. So type in named, we'll call this our mask texture. And by default, we're going to use the sky essentially. So it's the T_UDK cloud mask here. Move this here. We're going to duplicate this like this, or copy and paste. Rename the mask texture to empty painting. And we'll rename this to painting mask. And we are going to change this to our, I think, painting we used for the input. No, just blank apparently I called it, which is a very stupid name. So blank. Then we're going to get another one which we'll copy and paste, and this one will be our complete painting. And so this is just essentially what it will look like once it's done, and we're going to blend between the two. And this will be dark, which is an even worse name. So this will be renamed to complete painting. So this, to be fair, is not a good name. Empty painting is better. And that will do it for all our textures. Now we want to do our mask. So we're going to make a 4 vector. Right click and say convert to parameter, and we'll call this mask tint. And for this, we'll just use red. If you want to change it, you can, but a sharp red or oranges seems to work best. Then I think we're still missing something. Yeah, sorry, okay. So before we actually do this, we're going to do one last little bit before that we need, which is a alpha. So we're going to get our mask texture here. And from it, we are going to add. So click A and left click to add an add node. Then we're going to say scalar parameter, not scalar blur, just do S actually and left click, that will work as well. Max alpha, S and left click again, min alpha, and min will be 0.5, max will be 1, and then we're going to have another one which is going to be our alpha, which is going to allow us to lerp. And then we're going to say exactly that, lerp or linear interpolate, plug in the values like this, drag them here, plug them into the add, and from this we're going to multiply our node here by our painting empty. So essentially it's acting as an alpha mask. So it would be actually, you know what, we'll do this a bit smarter. We'll get our alpha here and we will promote this to a named reroute, and we'll call this alpha mask or alpha painting. And so we'll use that instead. That way, if you have something that has colors, we can still just use the alpha the same way. So replace this with our painting, I think we called it, alpha. There we go. And then finally, we're going to grab our alpha again here, and we are going to multiply it here once more. And this is the same one, so make sure you do not change the name, because this just allows us to, here it allows us to lerp between two values. So even at 0, it will be 0.5. But here we want to make sure that even if it's 0.5, it is 0 at 0, so that we don't actually see the change. The change only occurs once this starts to move properly. Then we want to make sure we clamp this between 0 and 1, and then we put a named reroute, and this is going to be our alpha mask. There we go. And so we need the alpha mask for this section, which is why I wanted to do it first. So we're going to start by multiplying this by our alpha mask. We're going to clamp it to make sure it remains between 0 and 1. Then we're going to multiply it again, but specifically by the scalar parameter, so we can control the emissive. So scalar parameter, and we'll call this emissive intensity, like this. 1 by default, so that it at least appears, otherwise 0 is black. And we will turn this into a named reroute as well, called emissive, like this. And now we just have to attach everything into here. Actually, not completely. First, we have one last thing to do with the emissive, but actually, no, we can do it all here. So first, we're going to have an if node. So I think I and left click will give us an if node. Plug it into base color. It's going to give us an error because we haven't plugged everything in yet. First, we get our alpha mask for A. And for B, we'll put 0.5. Then we are going to get our complete painting. And we're going to plug this into superior and double equal. And if not, we're going to put it to the empty mask or the empty painting like this. Now for our emissive, we can't just plug this in straight away, or this one straight away. We need to get our if again. And this time, instead of 0.4, we're going to say, instead of 0.5, we're going to have it be 0.4. Here, 0.4. And we're going to have another one that's going to plug into our A, B, and A superior to B and A double equal to B. And for this one, inferior, we're going to put 0, like this. I'm just going to move all this. Actually, I'm just going to grab everything here and move it all to the side. There we go. And so this is going to go into our emissive. There's some errors because it doesn't know what this is. And this is going to also take in the alpha mask, like this. And this time we want it to be 0.5. And essentially what this is going to do, it allows us to say in between 0.4, 0.5, we do a certain color, otherwise we do not. So we're going to get our emissive here. And here we're going to put a 1 again. And I'm sorry, I didn't explain this. I'm doing this by holding 1 and left clicking. It creates a simple scalar parameter, scalar value. Then we apply. That's going to take seconds. There we go. And we'll actually make sure our alpha here stays between 0 and 1 by going to slider max and put in 1. There we go. So let's make a material instance for this. We'll call it MI puzzle painting. Yeah. Double click to open it so we can just see if this is working. Set it to a plane so we can see it flat like this as it should be. And we're just going to modify the alpha to see if this works. There we go. So we're indeed getting our change. Now I don't know why it's going over 1. It shouldn't be. Either way, keep it between 0 and 1. At 1, as you can see, it's complete. You get the full image. You still get these weird edges, which is a bit annoying, but why is that? Let me actually just do a quick check. Maybe we can get rid of that. I think we can do it very simple here. What we'll do is we will move this multiply and we will put another if statement here. And we'll simply say if our alpha here, so copy and paste it, if alpha is compared to 1 superior or equal to 1, so we'll put in 1 node and say 0, meaning no light. If it is inferior to 1, then we'll just put our emissive. And what this should do is mean once we reach 1, it will go to pretty much being no longer emissive and just being the normal completed painting by itself. Let's see if that worked. Let's check. Okay, I think that worked. The emissive isn't there at least anymore. It might also have to do with this. Yeah, it's an extra instruction, so I don't think it's efficient to do this, but we could also add one in here after and say, if alpha is 1 completely or superior to 1, then we just put the complete painting and we don't use anything, we don't use this. Let's just see. I think that should work and it should get rid of our weird little glitch there. So not that, sorry. We want to get our alpha again, not you. We want the alpha here. And if alpha is equal to 1, again, we pass in our complete painting. So if it's, if A is superior or equal to B, then we do that. Otherwise, we do our weird lerp here. So let's try again. Okay, so yeah, so it's working. Right now it is showing only the other version. If we start to go back, you can see the weird outline there. And once we hit 1, it disappears. And now even if we go over 1, it still stays the same. And if we go back below, it starts to scale back to the original one. There we go. Perfect. That's exactly what we're looking for. So put this back to 0. So that does it. Let's close this and this. In Pedestal now we can actually tell it what image we're trying to make. I believe we have a variable for that. Or not. No, I don't think we do. We just say on puzzle solved, play from start. Compile and save. And do we have... By the way, I need to check this. Is tick disabled here? No, it is not. Okay. So let's get rid of those. Now, if alpha, make sure it's the same wording here. And normally, if we solve this, puzzle door should be moved and opened. Is there any default settings we need to set in here? I don't believe so. Let's give it a try. So I'm going to move this about. I'm going to get our puzzle door from Blueprints, drag it in, and we're going to place it close enough because it needs to be at least 1,500 units close. We're going to move this to here, and I'm going to slightly increase the quality of my shadows, so hopefully we can see it clearly. And I'm also going to make the skylight a bit darker. So let's get our directional light here and just put it to 0.5. There we go. So now you actually have the lights, and I'm having some auto eye adaptation, which is a bit annoying. I think we need to be closer here to get the result we want, because we still need to add the painting. Actually, I just forgot that. Because right here, this is nice and all, but we still need our painting to actually be visible. So we need to set this to a plane. Sorry. Basic plane, orient it like this, and place it here. And we're going to make sure we set it to the right material, which is our mi_puzzle painting. And it needs to be rotated like this. So right here, if we move this correctly to get the shadow, okay, so that's not going to work because it's way too wide. So we're going to move this a bit back. We want to make sure the shadow more or less matches. It doesn't have to, it's not perfect, that's fine. It's just to give you an idea how it works. So I believe if we move this back even more, that will work, but I also need to make sure this is thinner because we don't need it to be so wide. And let's give it a look in 3D. There we go. So right now we're a bit too close, and we can just check that with our, there we go, this. And so that's more or less right. It may be glitching now, but what's going to happen is it's going to LineTrace and place it on top normally. So if we try and play this, it is still on top. Why is that? Let me just move this back a bit and see if that fixes it. Okay, so for some reason it's not actually moving towards where it's hit, which is a bit strange. Okay, well, for now we'll just test if everything else works, then we'll go to C++ and check that again. So if we go and interact with this and we try and line it up so it matches with the puzzle piece. There we go, it's solved. And nothing happened. So it solved the puzzle, but because it hasn't hit the wall for some reason, it's not actually doing anything. So as you saw, the actual effect did play, so this is working just fine, but painting complete is not. And we're going to go back to C++ by double-clicking this and opening Visual Studio, and we're going to check why it is not doing that. And this time we'll use live coding so that we don't have to go and compile the project from scratch again. I apologize for rushing through the more Blueprint side of things. It's because this is more focused on C++ than Blueprints, so I'm not taking as much time. If you want to see more about the Blueprint side, there is a whole other series doing specifically this whole thing in Blueprints. So if that's what you want for the details and why we do what we do in Blueprints, then check that out. That'll probably be a better place to get your answers. So our issue lies somewhere in here, most likely in our begin play with this. This is most likely the issue. The line trace is not occurring correctly, and so it is not hitting anything. And so because of that, this isn't getting attached, it's not getting moved. And because it's not attached, we don't know what our painting surface is, so we don't know what to unlock. So we're going to wait for this and wait for this to load, and then we will get to say what our line trace is. We will add some debugging so we can actually see if the line trace is actually firing correctly, because that could be the issue. Okay, so we're going to replace this because for some reason it's just not working. I don't know why, and it doesn't allow us to debug it very easy. So instead, what we're going to do here, instead of if get world, we're going to use our actual library here, which we imported but didn't actually use, which I'm surprised about. Yeah, so we use it for the interface, but it actually does have some other uses. So we're going to go into here and we're going to say Kismet system library, double : and we're going to call line trace by channel. That's not how you write it. Line trace single. And I think by profile will do. No. We'll do for objects. Objects will work. Actually, will objects work? Yes, it should work just fine. So line trace multi objects or for objects. And what we want to input here is the same pretty much. It's going to be a world context, which is just going to be this. Then we're going to say start, which is start, end, which is our end. And then we need to say what target we are looking for. So we're going to have to say, we're going to make an array here. So T array. And the type we're looking for, let me put a semicolon here. So this is target types. And what it needs to be is of type tenum as byte, so tenum as byte, e object type query, so e object type query. And so for this, we're going to actually set a default like this, and we're actually just going to get this double colon, and we're going to look for, I think it's query 1, and we'll do query 2 as well, which should be dynamic and static objects. So I think. Otherwise, we can make this a variable so we can control it in the editor. That also works. So target types is going to be there. And then we can actually say, do we want to trace complex? False, we do not. There are no actors we want to ignore. So we're going to say an empty array. Semicolon, comma again. And then we're going to say our debug type. And here we get to say draw debug trace, so the bottom here, and we can say for duration, and we're going to say actually, yeah, so before that we need to put our out hit, which is our hit out here, and we are then going to okay, sorry, my fault. Go back to this, and the reason is because this, I mistyped this, and it should be line trace for objects, or sorry, I think, let me just get this again, line trace for objects, and we're looking for line trace single for objects, and I accidentally put the multiple one, so because of that it thought there was some extra stuff. So then we're going to put a semicolon here because we need to add that we are not looking for self, that we want to ignore self, so true, and that should be done. Now remove the semicolon, drag this here and place this here instead, and it will do the same thing essentially, but it's a bit more efficient, and it still saves the same spot, so we have nothing else to change. Then we're going to do control S to save first, then control alt F11, and this will open up a little window for live coding. Now we haven't changed anything in the header, so this works just fine. So let it run, and once it's done, we can actually go back to our editor and test it. Okay, we're back in the project again. Let's give it a try. If we play, we should have a line trace that appears to our right here. And it does. This time it actually hits, so it actually works. So for some reason, the old system just the old LineTrace just wasn't working. So with this new one, let's go ahead and interact. So it's going to disappear in a second because we just tried to say 5 seconds. F. Let's try and line this up. There we go, that works. It's approximate and it's opening, and there we go, unlocked. We can walk through, our inputs are back again. If we walk over here, we can interact again with this. So that does it. Thank you so much for watching. It has been a lot longer than I thought it was. I thought these were going to be 30-minute videos at max with 5 of them. It turns out it was more like double that. So thank you if you stuck around all the way to the end. I hope you enjoyed, I hope you learned, and if you didn't learn anything because all of this is basic and I made mistakes, please let me know in the comments. I'm still learning C++. I just wanted to share this version of my project, and if there are any optimizations that can be done, any improvements, please let people know down in the comments. Thank you to everybody who has supported me on Patreon, and I will see you all in the next video, hopefully a bit quicker than this one. Goodbye.